today we're going to talk about using trig to find the area of a triangle and other regular polygons. Remember, remember we emphasized that the trig ratios only work for what? Right triangles. Right? Trig ratios only work for right triangles. That doesn't mean we only use trig on right triangles. It means those trig ratios I gave you, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Those ratios are only true for right triangles. So we're going to deal today with polygons, regular polygons, not just any polygon, but regular. What's regular mean? All the sides and angles are the same. That's correct. And so regular polygons, and for triangles that aren't necessarily right triangles. So we're going to use trig to find the area of these. And the first thing we're going to do, let me pause a second. Okay, now we're ready to go again. Sorry about that. I thought I had that cleaned off, but obviously I didn't. Just reminding you here the formula for finding the area of a regular polygon. We've used this before. And remember, to find the missing parts, we had to know the rules for special right triangles, didn't we? 30, 60, 90s, and 45, 45, 90s. Good. And so now we can do this for any regular polygon. So we're going to choose to use this pentagon today in our practice. And in your work, I know you need to do at least a hexagon and an octagon and another pentagon. But understand, they don't all give you the same information. In this example, I gave you what in this picture? What's that 8 feet represent? No?
I don't know what it is.
It's the radius. The distance from the center to the vertex is the radius. Now, you asked first, was it the apothem or the apothem? Where does the apothem go?
Right in the middle.
Right in the middle?
Right in the middle of the side. Yeah, that's what he said.
In the middle?
Yeah.
Perpendicular
Whole thing.
to a side. It's got to be perpendicular to a side. That's going to be my apothem. Okay? Now, what else do I need to know in order to find the area of this? The length of a side. Okay, good job, Bryce. We'll let someone else answer now. Nice, though. Needed your help. So S is going to be the length of my side, but does the length of my side fit my triangle? No. Maddie, you're shaking your head no. Can you tell me why?
No, I can't tell you why.
Okay. Can someone else other than Bryce tell me why? What's wrong with my side length up here and my triangle?
The triangle is only half of the side.
There we go. So if we call this X, then we could say my side is equal to what? 2x. Good job, Haven. So if S is my side, then, and X is the length of this triangle from here to here, the length of the side of the triangle, then the length of the side is going to be 2 times X. Because this apothem, right here, cut this side into 2 equal pieces, didn't it? Now, in the formula, does it say side anywhere? No, what does it say? Perimeter. So looking at this picture, how am I going to find perimeter?
Times by 5.
Yeah, times what by 5?
2x.
Nice. And 2x again was what?
The side.
Length of one side. So I'm going to go a little slower. I'm going to say 5 times S. And you're telling me that because there are 5 equal sides, and they're all length S. So the perimeter is going to be 5 times S. And then you jumped right to the fact that S is really equal to 2x. And so what is 5 times 2x equal to? 10x. So my perimeter is 10x, isn't it? Doesn't help me much yet, does it? Because I don't know what? X. Okay? And I don't know A, which is the apothem. What kind of a triangle did I create? Right triangle. That allows me to use what? SOHCAHTOA.
Don't stub your toe, guys.
That allows me to use SOHCAHTOA. Alright? And so, yeah, be careful. Don't stub your toe. You'll have to SOHCAHTOA.
See, he stole my toe.
Yeah.
That's nice.
Still funny. No matter how many times you use it, that's going to be funny. Just like how do you catch a one-eyed or a no-eyed deer?
Yeah.
I said it wrong. How do you catch a deer with no eyes? There we go. I have no idea either. All right.
Oh my God.
Moving on.
More puns.
Moving on. So, how do I find x?
11.
Go ahead, Bryce.
Well, I can say it. X. You defined it.
That's what he told me.
I don't walk up here, circle it, and say, here it is, I found it, woo!
Sure, that's how you do it.
Yeah,
Found it.
nice. How do I find the value of x? Ah, Bryce realized that he's got to find the angle first. What angle are we looking for? Go ahead, you can do it. I believe in you.
You'd have to do 360 divided by 5 and then try.
Okay, let's slow down here. This is what he's saying. If I draw all of these in here, how many equal pieces do I have looking at those green lines only? 5. And Bryce is saying all the way around, a complete circle is 360 degrees. So if I take 360 and divide it by 5, I get 72 degrees for each one of these angles. And then Clover is saying if I want that angle, I have to take the 72, the whole distance, and divide it by 2. So 72 divided by 2 is, or 36 degrees. 82 divided by 2 would be 41. That's all right. I forgive you. I love the fact you're trying to do mental math. I really do.
See, now would it be sine?
So now to find x, I would use sine, wouldn't I? So sine of 36 is equal to
X over 8.
x over 8. So x is equal to, no, don't get carried away, don't need your calculator.
8 times the sine of 36.
Okay. Now listen to me carefully here for a minute, please. If I take this number and round it off, and I find A and round it off, and I use those numbers to find my area and round it off, what do you think I'm going to do when I'm grading your test?
Round it off.
I'm going to mark some points off. Because your rounded off answer is not going to be correct. Okay?
So is that it?
So we cannot round this at this point. You cannot round twice within the problem and round again at the end and expect to get the right answer. So don't round. Right now, as far as you know, x is equal to 8 times sine 36. So how do I find perimeter? That was equal to 10 times x, right? So that's going to be 10 times 8 sine 36. So what is perimeter equal to? 80 sine 36. So the perimeter is this number. Again, if I round now, I'm going to have a problem later. So don't round yet. Don't use that number yet. Now, let's move up so we can see our picture. How do I find A, Abigail? away from my 36-degree angle? It's the adjacent. You know, this picture looks a little confusing now. I'm sorry. I had drawn that whole angle in, and that made it look like I was marking this half of the angle with A, and I'm not. A, just to make sure we understand, is this side here, right? And you're saying it's the adjacent side, and so what part of SOHCAHTOA should we use to find A? Cosine. So cosine of Abigail equals A over 8. The adjacent over the hypotenuse. And so A is going to equal 8 times, well, my 8s look bad. Cosine 36. I'm going to blame it on the recorder going at the same time. We'll try it again. I'll slow down a little bit. So 8 times cosine 36. That's correct. So what was our formula for area of a regular half? AP. Apothem times perimeter. Well said. So A, area, is equal to 1/2 of, what's the apothem? 8 cosine 36. And what's my perimeter? 80 sine 36. Now if my half looks like a 7, sorry. Now if I plug all that in my calculator, make my calculator look like that, and I round it off, I'll get the right answer. So do that on your calculator, please. Make sure you're getting the right answer. I'll pause the recording while you do that. I totally agree. It's 152.2. It's area. Were we in feet? 8 feet, was it that given?
Yes.
So it'd be feet squared. Make sure you label your units again, okay? Label your answer with units, I should say. All right? The advantage of the trig is, A, you don't have to remember the special right triangle rules. But more importantly, because some of you are really good at remembering things like that, but more importantly, it works for all polygons. Because it doesn't matter what our angle is anymore. Before, this would only work if I got a 30, a 60, or a 45 there for that angle. Now it'll work for whatever. Okay? When you're doing these problems, they don't all have pictures for you. And some of you are going to want help right away. And I'm telling you, first thing you need to do is try to draw the picture. It doesn't have to be perfect, but it'll give you something to look at. Label your apothem, label your x. All right? I was impressed, first period I worked with a couple students, and I didn't even realize it, but they took this part right here to heart so much that they treated that like that was a rule. Like I told them you had to do it that way. And so when they were given perimeter instead of the radius, or they were given the side length instead of the radius, or maybe you're given the apothem, they used this to help them find the perimeter. Now, they weren't all pentagons, so they didn't always have a 5 there, but they used it. Okay, they took it beyond what I anticipated. I was just showing you why it works and why we get this number here, 10x. Okay? And they used it that way all the time, and it worked well for them. So you can do that or not. That's up to you. The answer, final answer, was 152.2 square feet. Do we have any questions on this before we go to our next rule and our last example? Okay. In that case, I tried to make this triangle not look like a right triangle. And that's why in parentheses it says any triangle. using SAS. What's that stand for, SAS?
Triangle side.
Side angle side. So that means two sides in the included angle. And so copy the picture down, I'll pause, and then we'll get the formula. The rule makes 0 sense without the picture, guys. Label. So label your picture. Well, make sure you understand what the labeling is here. Notice that capital A is this angle, and the side opposite that angle is little a, isn't it? And then capital B is this angle, and the side opposite B is little b. Okay? And capital C is that angle, and the side opposite that is little c. In math, when we're labeling triangles, we consistently use small letters that are the same as the capital letter used for the angle opposite it. All right? The rule, whoops there. The rule that goes with this then is that area is equal to 1/2 BC sine A. Remember, formula for area of a triangle is 1/2 base times height. The base of my picture is B, isn't it? 1/2 is there for 1/2 base. And then this height, which we could show you, we could prove, we could take time to prove why it is. But that height right there, that length, is equal to C times sine A. Sorry, C times sine A. Remember, this is a right triangle now, this one I created right here. And so A, opposite A is H, and hypotenuse is C, so sine A equals H over C, so H is equal to C sine A, and that's what this is. Okay? I'm not going to take time to write it all down, just take my word for it. The trig ratio for sine helps us to find this height, and it's equal to what I've circled right here, C sine A. Okay? Some really wise guy a long, long time ago realized this and gave us this formula. And we can go back and rediscover it, or we can accept, hey, it works every time. And it doesn't have to be a right triangle. That's what's special about this. Okay? All right. What's wrong? Well, let's copy this down and we'll talk about it. Now that our pencils are sharp and we've got this copied down, what's wrong with this?
Not a right triangle.
You're right, it's not a right triangle, but that's not what's wrong with it. Remember, our formula works for all triangles.
That have all the same sides and angles, not without.
Okay?
Is that what you got?
Let's go back and look at this. Let's erase this drawing here. Now, if we look at this, the formula uses angle A and side B and side C. So where's A in relationship to sides B and C?
Jason.
Yeah, they're adjacent to these sides, aren't they? This angle's adjacent to these sides, or it should say these sides are adjacent to this angle. In fact, we could also say, using our terminology from Unit 4, it's included. It's the angle that's included by these two sides. So in other words, this side makes up the bottom ray of this angle, and this side makes up the top ray of this angle. So those two sides pinch A in between them, don't they? If we go back here, if I use this angle, I don't know this side, do I? Or if I use this angle, I don't know this side. But I do know this side and this side, so I need to know that angle, and it's not there. Oh, shucks. Anna, how do you think we can find that angle? Awesome. Every triangle's angles add up to 180. So if 64 and 42 add up to 106, if I I subtract 106 from 180, I find out this top angle is 74. I want you now to find the area of that triangle. Yep, find the area of that triangle. Use that formula right there. Find the area of that there triangle. I'm hearing complaints I don't know what B and C are. What are B and C here? Angles. No. Little b and little c are not angles.
You didn't say that.
What are they? They're sides. Where are they in relationship to the angle we're talking about in this formula? They're adjacent to that angle, right? So I told you here, which angle did we need to know? What is it? So that means in my formula, that's got to be angle A. So where is B and C?
6442.
No.
The side is 16.
Why does it have to be angled?
My formula only uses angle A and sides B and C. So when I look at my picture, if 74 is my angle, then that's angle A. And so if that's angle A, what side is this?
Hey.
Little a, right? And so that means the other two sides are what? B and C. So we plug them into this formula and solve. So area is equal to 1/2 of, what's B? Sure. What's C?
C18.
What's A?
Side of 74.
74. And I use my calculator, plug them in, round it out to the nearest tenth. Did you get Brett? 38.4. Okay? Any questions on that? Hi.
Hold on.
I'm sorry to interrupt. I was just wondering the tape measures that we have for Miss.